All right. Hi, fourth graders. Today we're going to learn about how electricity moves from one place to another through a circuit. So we'll be talking about electrical circuits today. We can't see electricity because electrons, the charged particles whose movement through a substance creates electricity, are too small to be seen even with a microscope. But we can see how electrons move even if we can't see the actual electrons. And we can do this by doing a static electricity experiment, and that can show you how electrons can move from one thing to another. You probably have some experience with static electricity if you've ever been shocked, and so you can understand a little bit more about how this works. If you want to try this at home, you'll need a balloon and a soda can and a piece of material, an empty soda can. If you don't have those materials, you don't have to do the experiment. Either way, watch my video. It'll either show you how to do the experiment or you might just watch the experiment here.
All right, so now you guys can try an experiment with static electricity. So what we're going to try to do is move some electrons around so that we can negatively charge this balloon. In order to do that, you have to take a piece of material. I have a flannel shirt, and I'm going to rub it against this balloon, and I'm going to move electrons from this shirt to this balloon, and then this balloon will have a negative charge because it will have more electrons. Right now, if I put this near here, you can see nothing happens with the soda can. But if I negatively charge my balloon by adding more electrons to it, then put it near my can, you can see that I can get the can moving. And if I add more, I can get it faster. And you guys can experiment with this and see how fast you can get your can to move, and how far you can get your can to move with your charged balloon by moving electrons from the shirt to the balloon.
Okay, so to understand a little bit more what's going on with static electricity, I'm going to have you watch this brain pop.
Ow, why'd you do that? Oh, thanks, I guess. Dear Tim and Moby, why do I sometimes get zapped when I touch a doorknob? From Sarah. That's an example of static electricity. Electricity is when electrons, the negatively charged particles in an atom, move from one place to another. In current electricity, the kind we use for power, there's a steady flow of electrons along a circuit. In static electricity, like lightning and those pesky doorknob shocks, there's usually a single sudden transfer of electrons from one place to another. In order for that transfer to happen, you have to have a buildup of electrons on a surface. Hey, what are you doing? Right now, Moby's building up an electric charge. The rubbing makes the balloon pick up electrons from my hair, giving it a negative charge. Because my hair loses those negatively charged electrons, it gets a positive charge. And the negatively charged balloon attracts the positively charged hairs on my head. Because opposites attract, right? I think it looked better before. Anyway, all the matter in the universe is made up of atoms. And every atom contains a certain number of protons, neutrons, and electrons. Protons have a positive charge, and electrons have a negative charge. Neutrons don't have any charge at all. So, when an atom contains the same number of protons and electrons, it has no overall charge, and it's considered neutral. Protons and neutrons are stuck in the nucleus of the atom. But electrons orbit the nucleus, kind of like the moon orbits the Earth. And electrons like to move around. In fact, if you rub two non-conductive materials against one another, those electrons can jump from one material to the other. What are non-conductive materials? Well, conductors are materials that electrons flow through easily. Metals are good conductors. Non-conductive materials, or insulators, don't allow electrons to flow through them. They include things like cloth, rubber, and plastic. Some insulators like to give up electrons, and some of them like to collect electrons. Most carpets are made of nylon and wool. Those substances tend to give away their electrons, leaving them positively charged. Your shoes, on the other hand, have rubber soles, and rubber is a material that naturally collects electrons. Remember how the rubber balloon pulled electrons away from my hair? Well, your rubber soles can pull electrons away from the carpet. All you have to do is walk across it, and the electrons will be pulled out of the carpet and onto the soles of your shoes. A force called adhesion is responsible for the transfer of electrons. You can build up a bigger electric charge by rubbing your feet against the floor. The more you do it, the more electrons your shoes will collect. Anyway, those electrons that your shoes pull away from the carpet stay stuck to the surface of your body. And if you touch a conductor, like a metal doorknob, the electrons will flow out from your body and into that conductor. And they'll do it really, really fast. The shock you feel when you touch a doorknob is millions of electrons flowing between you and the knob in like a split second. That's a lot of energy to transfer in a really short time, which is why shocks can be painful. So, if your home has carpeting, be careful when you're wearing shoes indoors. Right, Moby? Moby? Well, at least no one can see my hair now.
Okay, so that's a little bit more about how static electricity is working in that experiment that you just did. Now, when we light a light bulb or we run any of our electronics in our house, we're using something called current electricity. So when electrons flow through certain substances, like through a copper wire, they form an electric current. The electric current provides energy to power all kinds of things, from video games to refrigerators to electric cars. This is how electrons move through materials to create electric current. So I'm going to show you my family acting this out. You can act this out with your family at home to understand how a circuit is working. For this experiment, you need something to pass from person to person, and those are your electrons. Now, in the first experiment I'll show you with my family, you can definitely do that at home. You just need some kind of, like, I used golf balls to be the electrons, but you could find anything that you can pass around. The second part of the experiment involves an energy ball, which I know that you guys won't have at home, but it's still a really cool way to understand how the electrons are moving.
Okay, hi, fourth grade scientists. So in the last video, you learned about static electricity, and we saw how we can transfer electrons to a balloon and charge it by rubbing it with a flannel shirt. Well, current electricity works very similarly, except the electrons follow a path. They follow what's called a circuit. The word circuit actually is comes from a Latin word circuitus, which sounds like a shape to me. Okay, what shape does it sound like? A circle, exactly. And so the Latin word circuitus means to go around, like in a circle. So we're going to show you what a current could look like. So normally, an electric current will travel through a substance like a copper wire, but we're going to model what the electrons would look like. So I'm going to give a golf ball, that's an electron, to Kate, and a golf ball to Coach Sherman, that's an electron, and I have an electron. I'm the battery, actually. So I'm going to start this whole thing from moving. So we have to stand close together, and we're going to pass these electrons around and show how the electrons would move in a circuit. Ready? Go. And as long as we can touch each other and move around, our circuit is complete or closed, and the electrons will keep moving. Now, if there's a gap in our circuit, so Mr. Sherman, can you take a step back? A little bit farther so we can't reach you. Okay, so Mr. Sherman's all the way over there, and so I'm going to say go. Kate, try to pass your ball over. And I can't either. This is what's called an open circuit. So the electrons can't move. Your circuit has to be a closed circuit for electricity to work and for the electrons to move and to pass through the circuit. So now I'm going to show you with invisible electrons. So I'm going to take these golf balls back from my volunteers. And here I have what's called an energy ball. Now this energy ball is not lit up. I'm just going to use Kate as my volunteer right now. Kate, I'm going to touch this metal part here. All right, you touch the metal part. Nothing happens. Touch my hand. We just completed the circuit. It's a closed circuit now, but we can open the circuit, and we can close the circuit, and we can open the circuit, and close the circuit. And we can do this with even more people. So, Coach Sherman, will you help us too? So look what happens. Is that a closed circuit or an open circuit? Open. So now we have to touch Kate. Still open, close the gap, and it's a closed circuit. So I hope this helps you understand how electrons are flowing around our circuit. Thanks, guys.
Okay, so that's how the electrons move in a circuit. And next week, we're going to do some lessons about circuit building. And you'll see how you can use wires and batteries and light bulbs. And you can actually create a circuit where the electricity can flow through. So some important things to remember from this lesson. Static electricity is caused by the transfer of electrons, which makes an object negatively charged. The electrons want to be balanced. So if a negatively charged object comes near a positively charged object, the electrons are attracted. They like jump over to the positive object, and that's what made things move. Like if I have a balloon and I charge it up and I put my hair here, my hair will go out to the balloon. Current electricity also involves electrons, and the electrons flow along a material like a copper wire, and the electrons will move from negative to positive. If the circuit is closed, like a closed circle, the electrons are able to flow and the electricity moves and it works. If the circuit is open, like a circle with a gap in it, the electrons are not able to flow and the electricity cannot move and won't work. And when we start building circuits next week, this is going to be a really important thing to remember. Now, what I want you to do now that you finished watching the video and hopefully maybe tried out your experiments, there's a Google Docs for you to open up. And I just want to see what you learned today. So you're going to fill in your name and your classroom teacher's name, like Mrs. Neal or Miss Furlong. Then you're going to answer these questions. Explain what caused the soda can to move across the table in Mrs. Sherman's video or in your own experiment. And you'll type in the blue box. What is a closed circuit? What is an open circuit? And here you can write any questions about today's lesson that you don't really understand. And we're going to learn a lot more about current electricity next week. All right, have fun and stay curious.